All right, in section 5.3, we're going to talk about three big concepts. One is called expected value. One is called expected value. One is called variance. And one is called standard deviation. Okay, expected value, and I'm going to go off on a little bit of a tangent here. A twist on expected value is how we figure out your grades. Okay, so a twist on expected value is how we figure out your grades. So when we're looking at expected value, we want to know, we already know what the expected value of a discrete uniform distribution is, because it would just be 1. Because or 1/6, sorry. If we're looking at the dice thing, because the expected value isn't going to change for any variable out there. So if we're looking at dice and rolling dice, well, then our expected value would just be 1/6. Well, that's great. Well, what if we look at the car buying scenario or the car selling scenario? What would our expected value be? In other words, what would you expect the number of cars to be sold every day to be based on this distribution of probabilities? Okay, so it's not the same. Who is selling 5 cars? That person is rare, okay? It's possible, but it's rare. Most people are going to sell 1 car. So what is our expected value? What would you expect your salesman or your saleswoman to sell on a daily basis? So that's what expected value is. So when we talk about this, what we are going to use is our formula for expected value. And that formula is going to be E of x, which just means it's a function, but I've named it E for expected value. Okay, and I'm going to use a Greek letter, mu, to represent this. And that mu, remember that means the mean. That means the average. Mean or average. Okay, so we've already done that before. And the way I'm going to do this is it's going to be set up as the sum of x times f of x. It is the sum of x times f of x. So that's how we're going to figure it out. Now let's go back to your grades for a second. We have this set up as a quantity of cars, but let's say that your grade breakdown is 70% for exams and 30% for homework. Okay, do you agree that those are different probabilities? Okay, those are different weights, but that still adds up to 100%. Okay, now in this case, our value over here isn't going to be discrete. I just want to I just want to show you a different application of this same thing. Okay, so let's say that you get an 84% on every, or for your exam average, and you get a 93% for your homework average. How do I figure out what your grade is? Well, what I do is I take the value for x, I multiply it by the function, and then I add them all up together. So come back up for your grades. I've lost my calculator. Oh my heavens to Betsy. Hang on, I have to pause. Got my calculator. Okay, so what we do in grading world, okay, is we take your 84% times your 70%. Okay, so 84 times 70, and then 93 times 30, and we add those together. Okay, so 0.84 times 0.7 plus 0.93 times 0.3 gives you a 0.867. So for the course, you would have an 87%. That's how we figure out your grade. That is expected value. Okay, so what I'm going to do, though, is take this back to a more discrete. It's important to recognize this adds up to 100%. This adds up to 100%. These are all of your possible outcomes. Well, these were earned by you. Okay, so in this case, I've got discrete variables. And over here, these are measurable. So it's a little bit different. It's not like the dead-on application, but it still is how we figure your grade. It's the expected value of what you got in the course. So what is variance? Variance is going to be how volatile your data is. Okay, volatile means busy. I mean, think about explosions. That's what it is. Okay, so think about, is your data all nice and smooth and put together, or is your data all over the map? That's what we're trying to figure out. So that's what variance is. The issue is that variance is not very easily applied. It's kind of a number that we come up with and we're like, high five, that's variance. It's hard to apply and give meaning to that number. Okay, so what we do is we take the square root of the variance, and that smacks our data back into something measurable. And the standard deviation has the same label as what our initial variable was. So what did I just say in English? Up here this was quantity of cars, right? So down here, this is going to be measured in quantity of cars. Okay, so, and it's not going to be something discrete. It's going to be something weird like 1.175 or, you know, something weird. It's not going to be a nice, pretty number usually, but it'll help us measure. It'll give us an idea of the variance, but it'll tell us what it is, and it'll tell us what it is in terms of what we're measuring. Okay, so again, variance is a stepping stone to get us to standard deviation. So the variance is not used very much. It's a number that tells us how volatile our data is, but there's not really a scale to tell us what that number means. In other words, I don't have a point of reference. Come back up to your grades. If your point of reference is 100% and you end up with a 37%, that number has meaning to you. Okay? Variance is a number that's not going to have meaning. It's just a way for us to get to standard deviation, which is a way to measure this stuff in measurable terms. So what we're going to do, if I can remember how, is, did I just do it? I don't even know. Okay, so hopefully you are seeing my screen. I hope. I don't know if you're seeing my screen. All right, I had to check to make sure you're seeing my screen. So basically what I've done in Excel is I've set up our basic information. So you'll notice I've got our discrete list over here of quantity of cars. Here I went ahead and wrote down the probabilities. And now I want to show you, I realize, yes, this is in the book, but I want to show you how to do what we're doing. So in the book, this portion says, it'll say x f of x. You need to know that that's multiplication. So I'm going to take x times f of x. And what we're going to do right now is, first of all, come under here and make sure that those probabilities add up to 100. Okay? So I'm going to take equals, tells it to do a, when you hit equals in Excel, it tells it, hey, this is a formula. So I'm going to take the sum, and then I'm just going to highlight the cells that I want it to add up. And I'm going to close that, hit enter, and it says 1. Okay? So now what do I want to do to find expected value? I want to take my x value times my probability and make a list of that. So again, I'm going to come over here and I'm going to say take this cell times this cell, and I'm going to hit enter. And that gives me 0 as it should. Well, now here's a little fun thing. Do you see that little square right there? I'm going to come up here. Stop that. I'm going to come up here and I'm going to drag this down, and it's going to copy that for me. So now I have taken this cell times this cell, put it here. This cell times this cell, put it here. So it's done it all for me. I don't have to sit here with a calculator and fumble around. Excel is doing all the power for me. So what do I want to do at this point? Expected value says to take each variable times its probability, then add them all together. So I am going to add these 6 cells together, and I get an answer of 1.5. So what does my expected value mean? My expected value means my salesman should expect to sell 1.5 cars per day. Okay, now can you sell 1.5 cars? No, you can't. But they should be selling 1 to 2 cars per day. That's what you would expect based on these probabilities. Okay? So what I'm going to do at this point is recognize I just found mu, which is my Greek letter for the average. So come down here, and this is how we're going to figure out the variability. Okay, or the variance. I'm going to figure out the variance. So I still have my x column. I have another column that says x minus mu. Okay, so I already know that mu is 1.5. I'm going to take that value and square it. Okay, so what do? I'm going to take x minus mu. So I have this equals, I have this value minus, what is my mu? My mu is 1.5. So I'm going to say 1.5. Enter. And then what am I going to do? I'm going to drag this thing down. So it is going to take the value on the left and subtract 1.5. Okay, that is my process. The next thing I want to do is take that number and square it. Okay, I'm going to take that number and square it. So come over here and say equals, and I'm going to put this in parentheses so that it will take the negative and square it. Okay, and then I'm going to just take it times itself. I could say squared, but I'm not going to. All right, so times B11. So all I did was equals B11 times B11. Okay, so I have now squared it. So take that and drag it down, and it's going to go ahead and pull those values from the left. Okay? So what am I doing now? I now just have a list of f of x. I have a list of f of x, and those are my probabilities from up here. So again, what are we trying to find out at this point? We're trying to figure out what the variance is. So I am now going to follow and say that, okay, I need this value that was squared, which is this column, times f of x. Now what your textbook says in a little bit neater way is it says x minus mu with an exponent of 2, f of x. So recognize that that just means I've got a multiplication problem here. So what do I want to do? I want to take this number times this number and put it in this column. Okay, that number times this number. So I'm going to take this one times this one and put my answer in that final column. So I get 0.405, and then I'm just going to drag this thing down. All right, so I now have all that answer. So what I would like to do at this point to find sigma squared, which is the variance, is I want to add that column together. So to find sigma squared, which is the variance, I want to add this column. So equals the sum of, why did I stop typing? What is going on? Sum, hang on, I've lost control. Okay, I don't know why it wasn't typing. Anyway, the sum of these numbers here. And hit enter. So I find out that my variance is 1.25. Okay, and again, that number doesn't have a point of reference. It doesn't have a label. It doesn't mean any of that, or it doesn't have any of that, which means it's just a number. What does that mean? So since I have squared things here, I can unsquare, okay? And that will give me sigma, which is my standard deviation. So let's do this. And I have SQRT, which is the square root. Why are you not typing? It's just fritzing. Hang on, let's pause. Okay, so let's try this. The square root of, why is this not working? Hang on, let's come down here. There we go. Okay. Square root. I'm trying to figure this out with the technology I have. So this is going to be Q. Square root. SQRT is what I'm looking for. Of what? I want the square root of that in that column. Hit enter and I get 1.11803. Okay, so what that means is the standard deviation is going to be a little bit more than 1 car. So what does that mean? So let's come back over here for a second. I have this one. I have this one. Okay, so standard deviation, we just found out that my expected value was 1.5 cars. I found out that the variance was 1.25, which again, I don't have a label for that. It doesn't have meaning. It doesn't have context. But when I took the square root of that, I found out that my standard deviation, which we are now going to reference as a lowercase sigma, so it's like a circle with a curly Q on top. Take the square root of both of those, and my standard deviation was, I forgot, 1.11? Sure. Okay, so my 1.11. My standard deviation was 1.11 cars. So we're going to find out later that I can add or subtract this number here, and it will encompass a majority of my data. Okay, so in other words, I can add 1.11 cars to this, or I can subtract 1.11 cars from that. Okay, so 15 minus 111 is 1.5 minus 1.11 gives me 0.39. And 1.5 plus 1.1 is going to be 1.5 is 1.61. So most of my salesmen will sell between 0.39 cars and 1.61 cars. Or sorry, 2.61. I can add. I swear I can. All right. So most of my salesmen will sell between 0.39 cars and 2.61 cars. That's where a majority of my data lies. But that is the power of taking that square root and using the standard deviation. So that is it for this section.